Okay. So, we're looking for square root equations. Hello, hello. And I promised you that I would get you a video before the weekend is up. And that's what we're going to do. Alright. So, let's start. Let's do a square. Oop, not this side. Let me try this side. Square root. That's a little bit better, right? So we got 2x plus 3. 2x plus 3 minus the square root of x plus 1. Look, you guys, I'm all the way at home. Equals 1. Right? You see? Can y'all see that? I know that markers are a little, it's on its last leg, but it's trying. It's trying, right? Okay. You like the backdrop? This is what the home videos look like. Okay. So can y'all see that pretty well? We got the square root of 2x plus 3 minus the square root of x plus 1 equals 1. So when we're doing square roots, when you're on the square roots, you want to focus on, remember I always tell you it's about the rules. So everything in math has an opposite, right? If you were to square something, remember when you are working with something like 4 squared, you're asking yourself, what did I multiply times itself? I multiply 4 times itself 2 times. That's going to give me 16, right? So then when you come back and you say the square root of 16, then it's like, what did I multiply times itself to give me that? Pay attention to this part right here. Let me see if this marker works. This part, squared, and this part. Those are, don't even do all of that. Let's just circle this if we can. All right, those are opposites. Those are inverse of each other. Just like I tell you that the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of squaring something is taking the square root. So, by now you've done this property, or hopefully you've learned, is this that marker that wasn't working? Hopefully you've learned already that if you are given the square root, oh wow, you gotta excuse the home markers, you guys. The home markers are, they at home, they on the weekend, you know what I'm saying? They on break. Don't mind, look, mind these people in the background, you guys. Get out. All right. Will you stop? Look, I'm posting this video just like it is. Keep your fingers out and get out. You guys. Okay. All right. So keep your fingers out. Hopefully you've learned that the square root of x squared, right? That means x squared we know that we can break down. So just like right here, 4 squared, x squared, and we had the 4 squared is equal to 16, just like the square root of 16 is equal to 4. So that's what's happening here. As you know, when we take the square root of things, we're looking for a pair of a certain value. So these end up canceling each other out, right? And that's how we're going to use that rule, that property, and that's how we're going to solve these. Get out. Come here. Come here. Look right there. You see this? Come here. Come here. Come here. This is the problem, you guys. Get out. Get off and out. Stop. I'm posting this video on YouTube just like this. Get out.
That's your fault.
Get out. Close the door. All right. So now that y'all had a little comic relief there. All right. I'm glad y'all had fun. Oh Lord. So anyway, if y'all make noise, you guys, you are messing with my YouTubers. trying to do the math. Oh, Jesus Lord. All right, y'all. So here we go. As I said, that's what we're going to use, the square root rule. So we're going to start by moving one of these radicals to the other side of our equation, right? And because this was subtracted, what do? When we move across the equals, we always use the inverse. If we're on the same side, right? Because you know the equals makes a left and a right. If you guys could be quiet, that'd be great. The equals makes a left and a right, right? You have the left side of the equals and the right side. So anytime we move across the equals, we're going to use our opposite sign, the inverse side. If we're on the same side, we're combining like terms. All right, don't forget that. So I'll add x plus 1 to this side, right? So now that leaves us with, we have the square root of 2x plus 3. That's still under the radical. These have canceled out, right? Because cancel makes 0. When you use additive inverses, that's how you make 0. And that's going to equal, and now you have that 1, we bring this 1 down, plus the square root of x plus 1. Right? So I know I have I have limited space here. I think I can go to about right here. So I'll try to write a little bit smaller. So now we've gotten here, and again, we want to make the square root symbols go away. And how do we do that? We square both sides. Whatever we do to one side, we have to do to the other. Right? Due to this equal sign, so whatever we do to one side, we always have to do it to the other. And as we know, when we square a square root, those are going to cancel each other out. So you end up with 2x plus 3 is equal to, but now this you have to FOIL. Now hopefully you've already gone past that. You remember, we'll go to the side of our page and we'll FOIL that out, right? Because this is going to mean 1 plus the square root of x plus 1, and that's times 1 plus the square root of x plus 1, right? So when we FOIL this out, we have 1 times 1, which is what? 1. Then 1 times the square root of x plus 1. They're both positive, so we have the square root of x plus 1. Then we do positive the square root of x plus 1 times 1 being positive, so we get another square root of x plus 1. And then we have the square root of x plus 1 times the square root of x plus 1, which is the same thing as squaring. So now we're losing the radical, right? That's going to be the square root of x plus 1 squared, which leaves you with the x plus 1. Okay? And then, like I said, if you're on the same side of the equals, then you're going to combine like terms. And we know these two are our like terms. So we're going to combine them. We'll bring down our 2x plus 3. Right? And then combining our like terms, we get 1. And we'll go ahead and take this out of our parentheses because we held it just to show that we took the, we evaluated that. Combine these two because they're alike. So that gives us 2. Remember your rules of radicals, right? And then we're going to do plus x plus 1. So now we're over here, we're going to combine more like terms because we realize all constant values are always like terms. Don't forget that. So we're just going to continue to bring this side down because we're not touching this yet. We're not evaluating that. We're just going to bring that down. And then we'll go ahead, and like I said, that's a 1. And that's a 1. Now this is one term. So that 2 is connected with the square root of x because you know that's being multiplied. And we can't take it apart. So we're just going to combine these like terms. 2 plus 2 square root of x plus 1. And then bring down our x. Okay? Now, okay, we see, well, we have an x over here, right? We can't solve our variables for our variables if they're spread out everywhere. So we're going to go across the equals. And when we cross the equals, that means we're using our additive inverse, okay? So we're going to subtract our x from both sides so we can get it over here. Because whatever we do to one, we have to do to the other. So now 2x minus one of those x's is going to leave you with the x plus 3. Bring down your equals and you have 2 plus 2 square root of x plus 1. Right? Okay, so I think the video is probably cut off around that part on my camera, so I'm going to erase the top half up here, you guys. I'm going to leave the original equation, but I'll probably erase some of this top half, okay, and I'm going to continue up there. So, if you haven't done so, write it down. If you haven't done, how many minutes I got?
18.
That's how many have gone?
It says 18, 25, 24.
Oh, okay.
You got 18
So,
minutes left.
so you got my little helper in here. You know, this is the first home video, so you guys welcome. Ooh, you get to see me at home. So anyway, make sure you get this down. Make sure you're attentive to all the steps because I'm going to have to erase it so that I can continue. So let me grab my eraser, my little wet paper towel here. And I'm going to start, I'm going to go ahead and get rid of all of this. And maybe I can erase this so you can keep the original problem up there. Right? And then I'm going to leave that so I can rewrite it up top. Okay. There's that. Yes, this is my own. I do have a whiteboard at home. Isn't that silly? I actually have 2 whiteboards. The other one kind of is like a picture. All right. So we were bringing down the x plus 3 is equal to 2 plus 2 square root of x plus 1. So again, the whole point of this assignment, you are solving square root equations. Your purpose is to recognize what to do when you have square roots and kind of pay attention. You know, rules don't change. This is how you solve it. You're still solving for x, but x just happens to be underneath the radical. So you have to incorporate the rules of radicals first before you can get x by itself and solve for it. And that's all we're doing. We're just going step by step. We're eliminating the radical first. As you see, we're still doing the same thing. We combine like terms if we're on the same side. We use our additive inverse if we have to go across the equals. Only thing different is that we've incorporated this square root and we've used those rules. All right. So we're still not done. We still have a square root over here. All right. So let's see. What do we do? Rules don't change, right? What did we do the first time? Let me grab another marker. Let's go with green. What did we do the first time to get rid of our square root? We squared it, right? Rules don't change. We're going to do the same thing. So we'll square this side and we'll square this side. And so yes, that does mean that we're going to have to FOIL again. Or before we square it, you know what? Before we even do that, hold on. I'm jumping ahead. Because I see I can combine more like terms. Right? I see I can combine more like terms. Where are they, you say? Well, that's a constant value and that's a constant value, right? The 2 is a constant value and the 3 is a constant value. So combine those like terms. I don't want to have to FOIL that again. Seems like I'm going to end up with another radical if I FOIL that again, right? So let me see. Let's move this 2. And this 2 being positive, that means we're going to have to use negative, right? Negative 2 here, negative 2 here. Bring down our x. What is 3 minus 2? Positive 1, right? Because the 3 is positive, 2 is negative. Bring down our 2, square root of x plus 1. And now we are ready to square both sides again. And I think I'm going to keep my pink. Right? So we're going to square this, and this is going to be one of those perfect square binomials. Do you remember the perfect square binomials? Remember, your first term is going to be squared. X squared plus 2xy plus y squared. Look on that, all right? Again, x plus 1 times x plus 1. What's x times x? What's x times 1? Remember your FOIL. 1 times x. And 1 times 1. And then you have your like terms. Alright, so x squared plus 2x plus 1. And then this one squared. Now this, you're going to square the outside and then square the radical, right? It means the same thing. It means 2 times the square root of x plus 1 times 2 times the square root of x plus 1. 2 times 2 is what? And what's the square root of x plus 1 times the square root of x plus 1? Well, we know. That just makes it x plus 1 from underneath the radical. So here, you're going to do that thing that you love to do. Starts with the D, means multiplication. Distribute, yes you are. So, bring that down. 4 times x, 4x. 4 times 1, positive 4. Bring all of this down. And what did I tell you we always do? Oh, the camera stops. You can't see right here?
The camera stops right there.
Right there?
Right there.
Oh, man. All right. So she said the camera stops right here. Does that mean that y'all didn't see that last row? Hopefully you did see it because I tried to pull it up here, right? Right. Okay. Well, she said the camera stops right here.
Also 12 more minutes.
Can't I do it right here, though?
Nope.
Oh, my God. Now I got to pull that up, too, and erase that. You guys, I'm going to have to get a bigger whiteboard or something if I'm going to be doing this at home. Alright, so now I got to erase this line. Okay. Alright. So, I'm pulling this up here. I'm just repeating. This is the original equation. I leave the original equation up so you can see it, so you can practice it. I'm going to pull this up right here so we can work with it. X squared plus 2x plus 1 is equal to 4x plus 4. Alright, so where were we? We were getting ready to do our favorite thing in the world, which is what? Combine like terms. Again, no like terms on this side, so we're going to have to move across the equals. Meaning we'll use our additive inverse. Y'all hear me? I keep saying the same thing because you do the same thing over and over. That's what I want you to see, this big pattern in math. X squared, bring that down. Positive 2x, negative 4x. What does that make? If my signs are different, what do? My signs are different. I subtract my values and I keep the sign of the biggest number. I'm going to subtract these two values. 4 minus 2. 4 is bigger, so my answer is negative 2. Minus 2x plus 1 is equal to 4. And then what am I going to do? Across the equals again. Again. This is it, you guys. Over and over and over. Minus 4. Minus 4, x squared minus 2x. Same rule, signs are different. Minus 3 is equal to 0. So now you have a polynomial, and what do you do with these? What's that word? We factor, right? We're thinking, what if my factors are negative 3? What did you multiply to get negative 3? You either did negative 1 and positive 3, or you did positive 1 and negative 3. How can you combine those two factors to make a negative 2? Looks like you have to use a positive 1 and a negative 3. That means you multiplied x plus 1, x minus 3, right? And because it's set equal to 0, you're still going to continue to set that equal to 0. And remember, you guys, here's that rule that everybody forgets. This is why I love hidden figures so much. Because in the beginning, she tells you, if you're multiplying and your answer is 0, then one of your factors has to be 0. So you set each factor to 0, and that's how you solve for x. X plus 1 is equal to 0. And x minus 3 is equal to 0.
That ends right there.
Minus 1. No. Plus 3. X equals 1. And x equals 3.
I can't see that.
Oh my gosh.
I can only
They
see.
can't see that? Okay, you can't see that? Well, here. It's over here. X plus 1 equals 0. Minus 1, minus 1. X equals negative 1. Or x minus 3 equals 0. Plus 3, plus 3. X equals 3. So your answers are negative 1 and positive 3. And so technically, just so you know, you could take each of these values and substitute it back in here and see which one makes a true statement. So negative 1, 2 times negative 1 is negative 2. And negative 2 plus 3, my signs are different, so I'm going to subtract my values. 3 minus 2 is 1. 3 is positive, so it's positive 1. And if you use this negative 1, right? Negative 1 plus 1 here, that makes 0. So the square root of 1 minus the square root of 0, and yes, you can take the square root of 0. Do you know what the square root of 0 is? 0. Do you know what the square root of 1 is? 1. 1 minus 0 equals 1. Try it with the 3. Let's see what happens. 2 times 3 is 6. Plus 3 is 9. Right? 3 plus 1 is 4. Okay? The square root of 9 is 3. The square root of 4 is 2. 3 minus 2 is equal to 1. So I told you before on many a video ago that you could always check your work and you could always make it 100. And we just did that, right? So there is your square root equations. I'll do another one, but apparently I'm being told I only have 7 minutes to do another one. So I'll have to, now it's 6 minutes. So I'll just upload this. Let me know. I'll look for one that's a little bit more complex if you want. Or I also was asked to do some exponents. So we might jump on some exponents. But either way it goes. Thanks for watching. Subscribe. Get everybody to subscribe. Send me more requests. And I'll see you soon.